Hi, I'm Keith Coffey, Senior Applications Engineer for Isolation Products at Silicon Labs. The end applications for isolation devices such as a CMOS digital isolator, optocouplers, and gate drive transformers total approximately 3 billion units annually. While isolators are used in literally hundreds of end applications, nearly 75% of these applications are in the industrial, medical, and security markets. So, what is isolation and why is it required? Well, galvanic isolation can be defined as a high impedance separation between two electrical circuits to prevent current flow between the circuits, yet still allowing information or energy to be exchanged between these circuits by means other than a wire or other metallic connections. Now, the heart of the isolator is its isolation barrier. The impedances typically exceed 10 to the 9 ohms. That's quite large, and it's virtually an open circuit. Now that you know what an isolator is, why is it useful? What types of systems need isolation? And in those systems that need isolation, what problems are being resolved? Systems use isolators to provide or resolve three main issues. The first is to provide safety protection. Safety protection is probably the most common use because any voltage greater than 60 volts DC or 30 volts AC is considered a hazardous voltage. End users of equipment must be protected from such voltages. The second most common is level shifting. Now there are two types of level shifting. You have absolute level shifting and common mode grounds level shifting. The third most common application is ground disturbance elimination that might be caused by, say, high current switching motors. If your sensing circuit is on the same ground, that noise could get introduced into your ground plane, into your sensing ADC, and corrupt the actual data conversion that's being sent to control the loop. Here's a safety isolation example of a typical high voltage switch mode power supply that converts a 400 volts high voltage DC input to 50 volts DC on its output. The low voltage on its output is safe to touch and can be used to power modern day electronics like microcontrollers and DSPs. The inherent problem with this design is that the control electronics has the same ground as the end user. Should the control electronics be damaged, especially if they fell short, the end user is exposed to potentially lethal voltages which can cause bodily damage or death. So how do we protect the user against such an event? Well, an isolator is inserted into the control path to isolate the input and the output circuits, yet still transmit the necessary control information between the circuits to ensure that the output regulates as designed. With the isolator in place, a damaged short circuit control circuit is blocked from the end user. Here's an application that demonstrates an isolator's attributes of both safety and level shifting. Battery management is critical for lithium-ion batteries used in electric and hybrid electric vehicles. This system maintains the battery's charge status, protects the cells from damage due to overcharging, and prolongs the life of the battery. It also communicates the status information to the engine's primary electronic control unit. Battery arrays can be hundreds of volts and considered potentially lethal. In addition, common mode grounds must ultimately be level shifted to the ground of the system. One isolation device can perform both tasks seamlessly. Here's another example that illustrates a solar power conversion system. Solar power systems require a power inverter to connect to the home or grid. These panels output DC voltage that must be converted to AC as most home appliances operate from 50 or 60 Hz AC power mains. These systems operate in noisy environments, must work over extended temperature ranges, and are required to last 20 plus years. The longevity requirements help offset the upfront installation cost. Silicon Labs isolators are ideal here because they operate at 125 degrees C and support a mean time to failure of greater than 50 years, far exceeding the optos that average well less than 20 years. Now you know isolators can be used to resolve numerous applications issues. They can be used to provide protection for the system and for the end user. They can be used to level shift not only absolute logic levels from say 3 volts to 5 volts or 5 volts to 3 volts, but they can also be used to level shift between common mode grounds up to say 1000 volts. The other primary thing is to eliminate ground disturbances, and that is inherent just by the fact that you're using an isolator. Here are 3 diagrams that show how Silicon Labs isolators are used to resolve these issues. To learn more about the isolation and isolating products offered by Silicon Labs, log on to www.silabs.com/isolation and have a closer look at these robust high-performance digital isolators and IsoDriver families.